Hello, my name is Shubham Ghosh, and thank you for attending Unlocking Your Competitive Advantage in Fabrics and Composites. Just in case you guys don't know, I'll have one slide about who we are. Cap Inc. is New England's reseller of SolidWorks, simulation, data management, all sorts of different types of software, and those rapid printers you hear about in the news. Again, another competitive advantage there. This is me down here. I'm at Cap Inc. in charge of making sure that those pieces of software work with your specific workflow, that they make you guys faster and not slower. Let's do a poll real quick to see who the audience is, and then we'll get started with the webinar. So I'm going to launch a poll here, and we'll see what industry folks are in. All right. So go ahead and vote here. You can vote for more than one, and I'll share the results here in a second. So it looks about 50% of people have voted so far. Okay, about 70% of the people have voted so far. Go ahead and vote if you need. Vote early and often, as they say. Okay, about 80%. I'll give it about 10, 15 more seconds. Last chance to vote. We'll see who we've got. Oh, I shouldn't have put that other category on there. Everyone's choosing other. All right. I'm going to close the poll now, and I'll share the results. Okay, so this is what we've got. And again, for the exact flat guys, I'm going to turn it over to you. You guys can take a look at this as well. About a fifth of you said you guys were in clothing, shoes, apparel. That's good. Almost half said you were in consumer product design. That's great. Surprisingly, a fifth of you said you were in composites, fiber, carbon nanotech, things that are laid up soft but then become hard. No covers and insulation, and then the 36% other, which I shouldn't have had that cop-out category. But okay, so that's what we're looking at today, which is good. We're going to talk about there you go. There's the camera. So we're going to talk about unlocking your competitive advantage. We're going to show you a software called ExactFlat, and we're not just showing you to show you a cool piece of software. We're trying to show you something you can leverage against the people you're competing against. For example, I've got a bicycle seat here. The bottom of the bicycle seat lends itself perfectly to being made in SolidWorks. You've got nuts, you've got bolts, you've got tubes, you've got things that are hard, okay? Lends itself perfectly to SolidWorks. The top of the bicycle seat, you could make the surfacing, the curves, you could do all that in SolidWorks, but if it takes you guys a week to make this into a physical prototype for testing, and it takes your competitor a day, there's an advantage to them. So you can see all the seams, all the leather, all the stitching. What I'm going to do, I'm going to throw it over to the ExactFlat guys, and they're going to show you how to take something like this and go from CAD to a flat pattern to your prototype faster than you ever thought possible. All right, so let me get rid of my camera. I'm going to turn it over to Keith. I'm going to make you the presenter. Okay, Keith, the floor is all yours.
Okay, terrific. Thank you very much, Siobhan, for that introduction. I'd like to welcome everybody here today. My name is Eaton Donald, and I'm joined today by application engineer from ExactFlat, Keith McQuan. And we're going to run you through a workflow using ExactFlat. And just to add additional context, most of the customers who use our product start with a CAD file or a CAD design, and really their objective is to get to the cutting table as quickly as possible. There could be other possible outcomes, so it could be 3D CAD to document for assembly instructions, white samples, cut lists, things like that, or it could be 3D CAD for costing. The main purpose today in terms of why we're here, we want to really share with you some of the best practices to help your team achieve up to 90% productivity gains with the existing resource footprint that you have today. And when we say 90%, we truly do mean 90%. We're going to achieve that in a number of ways. And just before we get into the actual live product demo, I'm going to just run through some of the top-level workflow items associated with our product. So when we talk to customers about what they're currently doing today, certainly they're able to get their product out the door, and they're able to compete, and they're able to successfully get the job done. But that's not without some problems. And what we find when we look at the soft goods workflow, and this is in direct contrast to, say, a mechanical or hard goods workflow, is that we have these process gaps. So they'll have a 3D design or even a 2D design. The first challenge is creating initial flattened patterns. That's disconnected from the design in terms of there's a different process and there's different technologies used. Often it's manual process. The second thing is then adding pattern features such as notches, seam allowance, grain lines, the things that really bring your patterns into a manufacturable form. And that again may be different from your pattern creation process. The same thing goes with a nest, and the same thing goes with getting your product in production. These process gaps are where there's waste and waiting, and when quality issues come in. The quality issues come in because often design changes have to be propagated manually through each of these successive stages, and that adds overall waste and waiting. Now what we often say is we are really targeting the tasks and the areas of the workflow that are characterized by waste, and we define waste as anything that your customer is not willing to pay for. So if there's something that you're doing today, perhaps rekeying data, any administrative a process that's associated with getting your work done, that your customer is not willing to pay for, that would be waste. And waiting is things like, queuing things up, scheduling workflow items and things like that. So that's kind of the top line challenge. Let's see how that breaks down a little bit in terms of the individual pieces. So I'm going to focus on three things, and this is not necessarily all the challenges that companies or customers have, but the first challenge is making patterns. So for example, if you're starting with a design, and everyone knows the efficiencies of using modern design tools like SOLIDWORKS, the first challenge is getting to a pattern, and often that requires a round trip through manual process into a state where you've got your patterns. We're going to show you very quickly how this can be done in a matter of minutes versus in a matter of days or potentially longer. The next challenge here is in estimating your material yield, and really the speed with which you can estimate material yield. This directly impacts your ability to optimize design and to optimize cost. So this is the first major cost bucket, is how much material am I going to use in making my product. And a different design may use have a different cost footprint. So this is directly connected to profitability. This is directly related to your ability to win business. This is directly related to your ability to gain market share from your competition. And the next challenge is maintaining accurate documents, and specifically connecting design, detailed design, into the things that need to be documented after the design is complete. So for example, assembly instructions for your manufacturers, design reviews for product development and business teams, could be cut lists or white samples for vendors if you're going to outsource. So this documentation phase we see as the final part of deciding, yes, my product is manufacturable, yes, it's going to be winning me business, yes, I can do it at a profit. So those are sort of three top-line challenges, and without any further delay, we can actually now get into the product demonstration part of what we're going to do today.
And actually, while they're switching over, this is Shivam. Any of you guys who have questions during the webinar, feel free to put it in the question window. I'll be monitoring it, and I'll pass it on to Eaton and Keith.
Thank you, Shivam. And Shivam, please feel free to interrupt should you want to insert a poll question in here along the way.
Oh, no problem.
So we're going to use a model of a shoe today for our demonstration. This is particularly applicable, of course, for the shoe industry, but also for those who are in consumer goods. And for consumer goods industries, those are industries characterized by a fast-moving retail environment where designs have to be efficiently produced because they're going to go on a store shelf for a particular season. If you're working in design industries, for example, that are in the retail segment, there's relationships with retail customers, there's competition for shelf space. All of those things relate back to how quickly and how effectively and how good your designs are. So we're going to show you how we can process this shoe design without having to go to a prototype. Now this shoe was initially created by a 3D prototype of a last which was scanned. So underneath this, which we're not showing here today, is a shoe last. The model you see here was modeled over top of that last. For other industries, so for example, if you're looking at upholstered furniture or other types of products, you can model in the same way, or you can model from other starting points rather than using a scan. But suffice to say, what we're going to do now is we're going to go from this CAD model to pattern geometry. And the way we do that is we use an initial tool here called our piece creator. The piece creator solves the problem of going from a faceted CAD model very quickly to a model with pattern geometry. So you can see all we do is we select pieces, and these pieces then are going to be knitted and welded together, and they're going to be analogous to the pattern pieces that we are going to use for our final production. And so this process takes a couple of seconds. You can see it's just a matter of clicking and selecting the pieces. If, for example, we were going to work with a layered model, so for example, say an insulation wrap or cover, or perhaps a composite product that had layers, you can see when we do select it and create the piece, it becomes transparent, and we can actually select through into underlying layers. So this process is very quick, it's very easy, it's a tool that's unique to the exact flat workflow, and we simply call it piece creation, which is short for pattern piece creation. And you can see that in in about a minute or so we've got our pattern pieces. If you just want to rotate around here, Keith. Okay, so problem that we're addressing here relates to the first challenge of creating patterns, and that is how to go from a CAD model to your initial pattern geometry. The next part of the process is we are going to just select convert to exact flat, so we just clicked OK. And now the toolbar becomes active here where we click convert to exact flat. And what we're doing now automatically is we're creating some reference information between the adjacent pattern pieces. So for example, where does one pattern piece align to a second pattern piece, its adjacent piece, and where does the beginning of the seam start and where does it end? All that information is being built right now, and it'll be used for subsequent processes. The next step in our process is we're going to assign materials. So here we'll just assign a sample material. And we're going to go into our flattener view. And again, what I just want to relate back to is the problem that we are solving right now is how to create your initial patterns. You can see that we have a 3D model view on the left, and we have a 2D pattern view on the right. Those are our initial flat patterns based on a fracture algorithm. And the color code that you see here is based on the initial mesh that we're given from SOLIDWORKS. We're actually going through a remeshing process right now, and this is a process to create a mesh that is going to be used for our subsequent simulation. The simulation is going to simulate the fabric stretch. So this is exactly what a master pattern maker would do. They would get the pattern pieces, they would throw them over a 3D form, and they would look for areas of stress and areas of sag or wrinkles, and they would try to eliminate them. And we start our simulation by providing an analysis mesh. The analysis mesh is used for the mathematics that go into eliminate the stress and sag here. And you can see it takes a couple of minutes. You get a status complete there in the second column. Here we go, to see on the remeshing process. And now what we do is we take the updated model and we start the process to optimize the pattern pieces. So you'll see if we zoom in here in the 2D side of things, the pattern pieces are actually being redrawn. We can just go in a little bit closer there. Yeah, let's just click on the toe piece there just for, so we can, yeah, there we go. So this toe piece here, the pattern pieces are actually deforming themselves. The polygons themselves are being deformed and manipulated in such a way to eliminate the stress, to eliminate the sag, and lastly, maintain these edge relationships. Depending on the complexity of your model, this will be an extremely fast process, or it'll take a little bit longer. So you can see that if we go to our pattern status, most of our pieces are complete, and we've got 2 pieces that are still to come, and these pieces are the ones with less formable surfaces. So these are surfaces which are more complex in their shape. Now we do support multi-threading. The process that you're looking at here, for example, if you're working on a computer with multi-cores, this will go faster because we will partition out the analysis, the mathematical tasks to different processors. The particular laptop we're working on today is nothing special. We're working on a Lenovo laptop with about 32 gig of RAM. Certainly not a blazing fast CAD machine. It's a machine that's you would expect to find for anyone doing work that requires some portability. And you can see that we've got all the pieces complete now except for the one. And we're just going to stop the optimization here. And we could let this run a little bit longer, but we're going to stop it here just to continue on with our demo. Okay, what we're doing right now is we're going to update our edge geometry. The edge pieces have changed, and so this is a rebuilding process that's going to just update those pieces. And the last step is to rebuild our product in SOLIDWORKS. And there you have it. Here are our pattern pieces. So if we go back to the very first challenge, and Shivam, I'm just getting a little bit of an echo here. I'm wondering if you just put yourself on mute real quick.
Sure.
Okay, that seems to have taken care of it. Okay, so we've rebuilt our pattern pieces, and now we're going to go to the process of just laying these pattern pieces out in a way which is analogous to the way they're going to be sewn together. And for us, it's a very simple process. We have a move tool. We simply click on an edge, and the program will automatically find the piece to which that is associated. And you can see that we can walk the pieces if we want to. It's simply a matter of dragging dragging the piece along the edge, and we can position them in a way that makes sense for the way that we're going to visualize how our product's going to be sewn together. Okay, and there's one more piece to go, and there it is. So we'll just pause here for a moment and review what we've done. So what we've covered so far is how to take your 3D design and create your initial pattern geometry. Then we took that initial pattern geometry and converted it to an initial flat pattern. And from that initial flat pattern, we optimized the shape to relieve the stress and sag. And so now you should have a good fitting 2D representation of what you designed in 3D. This has solved the process of going through manual process, creating a physical prototype, draping, and all the work that you'd have to do in order to arrive at an initial flat pattern. And there you have it. And probably it took us, I don't know, maybe under 5 minutes or so. So the next part of the challenge.
Yeah, Ethan, I want to jump in for 1 second. As a SOLIDWORKS user, to me this seems like magic, seeing this unfolded like this. But it's all based on math. It's all based on, just like our sheet metal package unfolds sheet metal. This is based on different but more complex math. So it's pretty amazing to us old SOLIDWORKS users.
Yeah, I'll just speak a little bit to that, Shivam. The process that a master pattern maker would go through would be one where they drape the form, and then they'd, through a succession of iterations, optimize the fit of that pattern. So they create an initial flat pattern, then they go through a process of either tucking in pieces or eliminating some material, or they'd go through a process of adding material where necessary. So they may do this, say, 20, 30, maybe 40 times, depending on the complexity of what's happening. This simulation for this particular piece has probably gone through about 1,500 iterations, and because we stopped the simulation a little bit early, there's probably another couple of hundred iterations to go there. So it is very much analogous. We built it in the way to think like the human would think, and it searches for things that the human would search for. That's why you can have confidence in the fit. And it's not just confidence from a theoretical standpoint. You'll see that the products actually do fit as well, or in some cases better than what the master pattern maker would come up with.
Yeah.
Now, somebody did ask a question about does it take into account the width of seam. We're going to get to that right now.
Oh, great. I was just going to bring that up. Good.
Okay, so we're going to go to our second part of the process now, which is putting in pattern features or seam allowances and notches and things like that. So you can see what we do here is we just select the edge. And when we select the edge, what we call the primary edge, the secondary edge will automatically be found and associated. And you can see there's a direction to this. The direction in which we are selecting the edges is analogous to the direction which these pieces are going to be sewn together. And for this, we have a lot of choices. So we give you, the user, the designer, the flexibility to put that, to select the edges in a way that makes sense for the downstream manufacturing. And that will have some significant implications later on when it comes time to costing, which we won't cover today, but if anyone wants to know more about that, we can certainly do that. So what we've done is we've selected a number of edges here. And you can see at the top in our property managers, we've got a number of edge names here, edge 3, 5, 7, 9, and so on. And we've also selected what we call auto add mate. So if you didn't want to have the mate automatically selected, if you wanted to have a different seam allowance on one piece versus another piece, for a variety of reasons, you're able to do that. But we've selected the edges. Now we're just going to go put a seam allowance on, and we'll show you how easy that is to do. We select seam type, and here we're going to put an 8mm join. And you can see that automatically all the edges are updated. Now we're going to go put some alignment notches for sewing in here. And we have a tool called the notch chain. So let's put a V notch in here. And there you have some alignment notches, and let's increase the count there. There we go. Yeah, let's put one more in there. And let's put another one in there as well. Okay, so you can see that it's very easy to select a number of notches, any number that makes sense, and those notches will be perfectly aligned. So what you will not have to do is walk these patterns. Recall during our flattening process we were making these edge references. These edge references now allow us to create these alignment notches at a push of a button, and we can do it in a very intuitive way. So we can finish this process off by adding edges to all of the pattern pieces, but we're not going to do that. I think you guys get the idea in terms of what's what the process is. So we're gonna stop there. And if you wanted to, if you had materials, for example, like a carbon fiber, you could add a grain line. If you had a place where you wanted to put markings, say for example, if you're going to put a logo or a patch or some reinforcement on, we could use SOLIDWORKS sketch entities to do that. But this is the second aspect of the problem of creating your initial patterns. We're going to go now to the second problem, which is how to create the nest. So from here, we click on View Markers. Now, recall when we added our materials, we assigned a material to our fabric during the flattening process. So all of the characteristics of that material, which means the width of the material, the grain direction, all that kind of stuff, piece gaps, edge buffers, has been automatically predefined for us. So we don't have to set that up. It's been done once, and now we can just go into creating our nest. And for nesting, we simply hit the nest button. So now we have a nest that's going to be created. The nest takes a little bit of time, which is maybe 4 or 5 seconds to initialize the mathematics. And now you can see it's already running on this particular a set of pieces. We can set constraints, lay rules with rotation and piece flipping and things like that. We can certainly customize those things. We can schedule the run time to be any time that would be desired, so we could batch up a bunch of nests and have it run overnight, or we could do, for example, in this particular case, a design nest, which is just really to see what the yield is based on our design, and the nest would run for a particular short period of time. So you can see that this nest here has got a very low yield, which is 15.58%, because we're nesting on a sheet. If this was a nest that was on a roll, we could actually just get the nest yield based on the amount of fabric that the nest itself is actually taking up. And the green bar on the right-hand side gives you an indication of progress, but that's how the nests are created. And if we go, just let's stop this nest right now, because we don't need to necessarily see the process complete. Oh, it's finished already. All right, so let's accept the result here. Okay, and let's go through a process of now getting this ready to export to be sent to a cutter. So we have a number of presets. We support the major standards in terms of cutting tables, ASTM standards and AAAMA standards. And you can set up presets depending on the type of table you have here. So for example, you can see there's a Lectra and an Eastman preset in this example. We've got presets for Gerber and a host of other tables. Let's export this one to an Eastman table. So we'll hit export, just give it a name, demo. And there is our nested file. You can see the notches are in there, and that will be the file that will be sent to the cutter.
I'm just looking at that file, Ethan. I'm just imagining how much human effort it would take to nest those things so tightly. It's just amazing.
Well, the other thing is for those customers that are already using automated nesting, they're accustomed to seeing files which are packed down like this. However, it is with much more design and process effort that it gets there. And remember what we said at the beginning, we're really trying to eliminate waste and waiting. So the designer now has on their desktop a button which they push and automatically they can generate a nest. Now the nest will inform how much material is going to be used. And if they have a particular mandate in terms of designing a product within a certain cost range, this gives them instant feedback on how they can make changes and where they are with respect to their design goals. So for industries like, for example, these fast-moving consumer goods industries that are highly competitive, now you can squeeze a couple of extra percentage points in product cost that will help you drive your business forward. Now I notice that we do have a number of questions here, so why don't I go ahead and just go through the question list, Siobhan, real quickly.
Sure.
And then we can go there. Okay, so the first question is, how about the particular material physical properties of stretchability, E-value, does that come into play here? The answer is yes. So when we assigned our material, there were a number of engineering characteristics that were associated with that material. Young's modulus, Poisson ratio, warp and weft, all the variables that you need to take into account in terms of defining what a good flat pattern would be. So we've taken all of that information and put it into a database. The database is set up once. So as a designer, you don't have to go through finding all that engineering data. It's a real time saver. And again, that goes to eliminating waste and waiting. You simply select the material from a list, and that material will come with the engineering characteristics. In addition to that, as I mentioned, it'll have grain direction, it'll have fabric width, piece gaps, edge buffers for building the nest and things like that. Okay, next question. Do you need to have your seam locations or panels defined before running the process? So the answer to that question is yes. Design intent must be reflected before you start the process. Now there is some flexibility. So for example, we can create our pieces different ways, we can put our seams on in different ways, but the program does not know what the user's design intent was. That's where user expertise and the technology work in unison to give you a good result. Okay, next question is how do you factor in stretch of a particular material? So we talked about this. Is it possible to account for asymmetric stretch? So that is a great question in terms of asymmetric stretch. So the program and the algorithms that we use do support isotropic materials. And isotropic materials, for those who don't know, are just materials that have the same stretch characteristics in the X and Y direction. So if I pull it on the longitudinal axis, it'll stretch a certain way, and if I pull it on the transverse axis, the stretch will be exactly the same. But for anisotropic materials, materials that have a different stretch characteristic in the transverse and the longitudinal direction, we do account for that. So you can put a Young's modulus in for materials that have a different stretch characteristic in different directions. So we have both isotropic, orthotropic, linear orthotropic, quintic orthotropic. I know it's getting very technical here, but there are algorithms that account for stretch and different material characteristics in a variety of ways. Okay, other questions here?
Well, let's do
patterns.
Eden, let's do this. Answer one more question, and I'll throw up a poll, and then we can kind of see where things go from there. So you can answer the question, I guess, about the cutters with the close edges, and then we'll throw up a poll.
Okay, so the edges are in fact very close here, and that is a setting that was assigned when we assigned the materials, and that's a setting associated with piece gap. So if we go back to our nest, if you would, Keith, please. Okay, and let's go into some of the properties we can adjust here with the nest. So we can edit the properties here, and you can see that we've got a variable here for piece gap, we've got a variable here for edge buffer. Now, what happened again when we assigned this material here called sample material, all of the information associated with that sample material came in with that assignment. Again, what we're trying to do here is we're targeting waste and weighting to give you a very efficient design process so you can improve your profitability. The piece gap and edge buffer are editable variables. However, the standard default piece gap and edge buffer that is associated with this particular material comes pre-populated from the database. It's a one-time setup, and then after that you don't have to set it up again. So this would imply you're going to be using a particular type of knife and a particular type of cutting process that's going to support this piece gap and edge buffer.
All right, good deal. Let me the questions are building up fast and furious here, but let's throw up one poll just to get everyone else involved. And we're going to ask them. So you guys have shown them a couple different steps. The poll I'm going to put up here is, of the steps they've shown you, which one takes the biggest time in your current design? There's the design itself, which is mostly in 3D, but there are things like preparing the pattern pieces, developing a cost, developing production drawings, optimizing the nest and yield. So go ahead and vote on this. And that'll give Eden a chance to look over some of these other questions and see which ones he can pick off. We want to make sure we get to everything in the webinar, so we'll do the best we can. And if we have questions, we've got your name and email in the question, so we can answer questions after the webinar if it needs. But anyway, keep voting. About 50% of the people have voted so far. All right, and again, we're trying to save you guys time in the manual stuff that may or may not, be value add all the time. Let's see if we can let the computer do some of that. All right, about 70% of the people have voted. I'll give you guys about 10 more seconds. Let the last couple folks go through. All right, keep voting again. Vote early and often. All right, I'm going to close this poll here, and I'll show you the results. So it looks like the biggest time chunk here was in design, which is where it should be. That's the value add. That's the human part of it. But look at that, 30% who say the biggest part of their time is in preparing the pattern pieces. As Eden just showed, heck, let's let the computer handle that part, and let's see if we can save that 30% of people some time. All right. Eden, do you want to answer a couple more questions, or do you want to show some more stuff in the software? I'll let you make the call.
Yeah, there's a couple more questions here. Why don't we go through and just close those off as part of this process. Okay. So there's a question here related to large continuous surfaces that need to be broken up into separate faces based on a minimum of stress and wrinkle. So if you have large surfaces, you can use SOLIDWORKS tools, essentially put a split line in where you want to break a surface up. That can either be done through using standard design SOLIDWORKS tools, or you put where it's a split line or a dart that would be put in there. So that's a fairly straightforward process as well. The other point I'll make about that is you can see, for example, if you had a large continuous surface, you could flatten it right away, see exactly where the large stress is, where you want to relieve, go back to your design, add a split line, add a dart in, and then go through the flattening process again. And this allows you to go back and forth very quickly to get that instant feedback in terms of how you can optimize your design. So hopefully that answers the question. And on this particular one, if you have more questions, we'd be happy to do an individual demo for you guys can have a look and see. The next question is, can the individual flat patterns be converted into SOLIDWORKS parts? And so the answer is yes. This is a SOLIDWORKS sketch entity. At the 2D phase, you can actually save those 2D flat patterns. If we just want to go back there, please. So the 2D patterns right here can actually be saved as a SOLIDWORKS part file. and you don't have to export it as a DXF. So if you're going to do some other processing and use it for other design or other decision-making part of your process, you can do that as well. Does exact flat write directly to Electra, or is translation required? So it goes, it can, the DXF files that are exported can be read and directly imported into the Electra cutting environment and directly cut on Electra table. If anyone has any questions about that, again, we'd be happy to do a live demo. We do have customers using Electra, Gerber, Eastman tables and a variety of other tables that, again, it's a one-time setup, and then you're kind of off to the races. The next question is, does this only work with surface bodies, or can it work with materials that have been thickened or into a solid body? That is a great question. So the model that you're looking at right now are knitted surface bodies. However, if it was a solid model, the piece creator allows you to pick faces on the surface of a solid model and use those for pattern pieces. So we extract the face from a solid, and those faces are used as input into the flattening and the patterning process. So you can work in a way which is the best for your organization. So sometimes you may have a scan, which would be a point cloud decimated into a surface. Sometimes it could be a solid model, model from scratch. The choice is yours, and we do have some examples of that on our website. Or you can just give us a call. We'd be happy to show you some more details about that. Okay, Siobhan, that's the question. So we're just going to quickly review before we go on to the next phase, which is documentation. So let's go back to our model view. So we started with a 3D model. We created pattern pieces from our pattern geometry. We went into our flattening process, and you can see we have made an analysis mesh and used that as a basis for flattening our patterns. And from there, we went into our 2D pattern view, and the seam allowances and notches were put on here. I want to emphasize this point. I said it before that we're really targeting waist and weighting. If you can look at the mouse clicks that we have made here, every mouse click has been for a specific reason to derive a specific outcome that is adding value along the process. And we believe that we've been very successful in, number one, eliminating any wasted effort along the way, and number two, eliminating any time that you have to wait for something. So the fact that we have our design, our pattern engineering, and our nesting all in one environment allows you to get this a result of getting an accurate nest very quickly without having to schedule pass work back and forth, rekey data, or anything like that. The next part of the process is going to be taking our designs and documenting them. And the documentation part of this is either for, it's for a variety of reasons, but it could be for, design reviews, it could be for assembly instructions for manufacturing, it could be for cut lists or white samples that you're going to build, or that you're going to send to vendors or third parties. So this is how we do it. We start with a template, SOLIDWORKS drawing tool template. You could customize it, or you could use one of the standard ones that are available. You take your pattern pieces and you literally drag them in to the document template. Here we're using a B block. We do support other sizes depending on your industry. So for example, if you use A, C, D, or even E size drawings, that's not a problem here. So you drag your pieces in, and you can see what comes in is automatically the pattern piece layout that you've created before, and the notches and the seam allowances and other pattern features that you would have put on here. What we're going to do now is we're just going to put some other additional information in here. So you click on the exact flat drawing tools, and I'm going fast here, so if I'm going too fast, please do ask questions because I am monitoring what's in the question box. We're going to put some tables in here. So let's go ahead and put a piece table in here. So here's a table of pieces. That's all the pieces that we have. So if your sewers need to make sure they got all the pieces in their order, this is the way to do that. We're going to put piece balloons on this. This is particularly useful if you're making products that have very similar pieces. So for example, for a lot of composite parts, they may have pieces which are very similar in size. they may be off by, you know, quarter of an inch or half an inch or things like that, and it's difficult to know which piece is which. Well, this is a way that you can help your assemblers and your sewers and your layup technicians to very quickly identify the pieces that are part of their task list. Next thing we're going to do is we're going to we're just going to change the layer type. We're going to put a material table in here. And if we had, for example, different types of materials, this is a shoe. We've just decided that all these materials are one, but we very much easily could have different, you know, types of materials for the heel cup or the toe cup or the side pieces, or perhaps a logo or something like that, or a reinforcing patch. All of that can be done very easily. Okay, so just continuing on here.
Now, I like how much you guys are making use of the existing SolidWorks tools. I mean, this is very similar to what sheet metal does. You know, it uses the existing tables, the existing, task pane on the right-hand side to bring the flat pattern in. So it's not a huge learning curve for the existing SolidWorks users, which I like.
That is a great point that you're pointing out, Siobhan. It was by design. We wanted, again, eliminate waste and waiting. And the best way that we can get people to be productive is if they're existing SolidWorks users. They know there's a lot of familiarity in the interface, a lot of familiarity in the tool sets, and even though it may be different things, but there's a property manager page that, you know, that is common to all of the SolidWorks tool sets. We've adopted those standards as much as they're relevant to be adopted. So the net result, the benefit for any user picking this up is, number one, they can learn it quickly. Number two is they can find trained people in a variety of places, or they can look at companies like Capping to help with their training and implementation process very easily. Okay, and let's just finish this off by putting a notch table in here. Now, I will say that we have these preset tables and we have these preset features, but if you wanted to put custom information on here, you could make your own table. You could put your own information in here just as easily as you are putting custom information. Now we're just going to finish this off with the notch balloons. So now, in a matter of, you know, say 30 to 60 minutes or so, you can have this whole project laid out for design review. And you could do it in a way which is very, very, very efficient, that allows you to focus on the design intent and the key objectives that your design is supposed to achieve, versus going through all the administrative work to get your designs you know, into the position where you're ready to review everything. So that's a quick run through. So documentation, let's just go back to our pattern view real quickly, Keith. Documentation is linked to the pattern view, and we're just going to make a quick change here just to kind of round things out. So we're going to take a pattern piece here. We're going to actually, let's change the piece name first. So we know that piece naming is a big deal for a lot of industries, especially ones where you have pieces which are going to be very similar. So we'll go back to our drawing view, and here you can see in our piece table, we just made the change from exact flat number 8 to the piece name sole, and then our piece color actually changed as well. It's very simple to make your drawings intuitive, straightforward. This helps with reducing errors. This helps with very efficiently getting everybody to understand what the designer had in mind, and now you're ready to manufacture. So I'm going to go back to those of you who are in the shoe industry or in consumer goods, or even in other industries where you have to make design iterations and design changes very quickly on the fly. You see that we can do that and accommodate those changes in a way that doesn't require you to have to chase your changes through a bunch of manual points in the workflow. Okay, Siobhan.
Yes.
I think that kind of runs through the bulk of the demo. We've covered how to create your initial pattern pieces, how to get to your nest, the challenge of how to create an accurate nest fast, and then the last challenge, which was how to create accurate documents quickly. All along the way, eliminating waste and waiting. And again, I just want to call everybody's attention. Every mouse click here had a specific purpose. There was a lot of automation that happened behind the scenes. So if anyone has any additional questions, we can certainly take some more questions at this point.
Yeah, absolutely. If folks can come in with questions, we can also then talk about next steps. I saw one question about pricing options that just came in, and what we'll do is, we'll contact people directly. There's a lot of different options to go through, network versus standalone and other things that we have to have a back and forth that we can't have over a webinar. So for the folks that are asking about pricing options, we'll call you guys directly on that with some help from ExactFlat. But yeah, Eaton, if you have, do you have slides for next steps, or I can finish up and we can let these folks go and enjoy the day.
Yeah, so we can, Keith, you want to just switch to the PowerPoint again? And again, what I'd like to do is just go back and review this one right here, please. So just before we do get to next steps, we talked a little bit about the challenge, and that the big challenge is really centered around a disconnection between the different process steps. And we think that ExactFlat is really the premier program for eliminating these disconnects. And we actually have a name for it. We call it link and shrink. We're linking the various processes and we're shrinking the effort. We didn't make that word up. That's a word that comes from lean manufacturing design or lean manufacturing, and we've applied it to lean design. So this challenge, if this is the challenge that you are having in your business, and if these challenges are actually creating scenarios where you maybe are not optimized in profit, if you're potentially having highly competitive marketplace dynamics where you need to beat your competition, or your reseller or your customer relationships are ones that are characterized by lots of changes, these are the challenges we fix, and these are the challenges we address, and we'd love to talk to you guys more about that. So with that in mind, we're just going to kind of wrap up here with next steps. So it's very straightforward for us to do an ROI analysis for your company. We can do it along a number of dimensions, but we need your participation. And for those of you out there, for your companies who do ROI analyses, who have a good handle and control of where your costs are, we need a certain number of inputs, and we can turn something like this around very quickly in partnership with Cap Inc. So for example, we need to know your current workflow. We need to know the picture in your mind of your ideal workflow state, and then we can start to look at an A/B comparison of the current versus the ideal state and estimate some time savings. And this is going to require that we know the priority areas to fix, because we may not fix them all. We may just fix the ones that are really the ones that are problematic, and then reserve others for later on downstream. So those are the two things that we'd want to do first. And in terms of next steps, we'd love to have a conversation with anybody in this call about what your current workflow is and why you think you want to make a change in some technology. That would be very helpful for us in putting together an ROI. From there, what we'll do is we'll put together an implementation plan. Implementations are generally pretty straightforward. There's two aspects to it. One is technology. One is getting your people up to speed on a new workflow and a new technology plan. And because, again, we're inside SOLIDWORKS, the learning curve is very straightforward. And then we can do a customized demo using a model that you have. I mean, that may or may not be necessary. I mean, the one model to the next is not horribly different for us, so that's a choice that you guys can make. And then lastly, we can do a presentation to you, your colleagues, whoever's involved on your side in terms of bringing new technology in to get things rolling. But it starts with the two critical first steps. What are you doing today, and what specifically do you want to fix? We're happy to have this discussion, and we look forward to further discussions. So there's one more question, Shivam, that came in, and I didn't catch it here. Is there a way to bring in a 3D DXF from other software to do the flattening? So typically, we haven't seen the 3D DXF because the DXF is a 2D. Well, we have seen 3D DXF. Pardon me, we have. But yes, the answer to that question is yes. So SOLIDWORKS does support a variety of file formats: STEP, IGES, DXF, and a whole host of others that we can bring in from other programs. So if you're using competitive 3D design software from some of the major providers out there, it's not a problem. We can bring those in and have been successful in bringing them in as well and putting them through this process.
All right, yeah, no, I answered about the same. If it can be imported into SolidWorks, you can do everything that was shown here. But yeah, Keith, if you make me the presenter again, I'll show folks the 2 email addresses that they can contact, and then we'll be done. All right, show my screen. All right, so again, a couple of next steps for you guys. If you want to see more videos, they've got a lot of different examples in a lot of different industries. You can go to exactflat.com. You can see a car seat. You can see other types of industries. If you want information on custom demo, you want to see it on your part file, email salesinfo@cappinc.com, or one of us, could be calling you in the following days. If you want that ROI study that Eaton was talking about, where we say, okay, how much does this step take you? How long does this step take you? And we kind of compare it and show you the return on investment, you can email me directly. I'm shivam@cappinc.com. Or if you email salesinfo@cappinc.com, it'll also get to me as well. But those are the next steps. Contact us if you're interested. If you just want to check it out, and the people who have asked about pricing, we'll be contacting them. Besides that, Eaton, all I had was this last slide. Bring it back to your competitive advantage. Do things in fewer steps faster and get the things out to market faster. That could be your leverage in this tough world out there. But thanks for attending. Eaton, do you have any last words? And if not, we'll end the webinar.
I don't have anything to add to your closing, Shivam. I just want to thank everybody for your interest in ExactFlat, and I would encourage you, if you have an interest further to know more, reach out to us. We love what we do. We think that we're pretty good at it, and we'd love to bring our expertise to your organization.
Awesome. All right, thanks, Eaton. Again, thanks for all your support, and thanks for everyone for showing up. Have a good one.
Okay, thanks.